Imagine the most powerful marriage in tech history, a union that built the very foundation of our digital world. Now, picture that marriage ending not with a whisper, but with a seismic rift. A rift so wide it threatens to split the global semiconductor industry in two. Not because of a scandal or a scandalous merger, but because one partner has decided the relationship is over. Permanently. What if we told you that the alliance between the world's second largest economy and one of Silicon Valley's most iconic companies is dissolving, not gradually but in a single decisive move? A move that could rewrite the rules of global technology, leaving one giant scrambling to find its place in a world that might no longer need it. Welcome everyone to Revo Now, where we decode tomorrow's hidden tech landscape today. Today we're diving into a geopolitical and technological earthquake that's already reshaping the ground beneath the semiconductor industry. Stick around, because what you're about to learn might just change how you see the future of computing, global trade, and national power. The question isn't just about market share or product performance anymore. It's about trust, dependence, and control. There's a specific moment, a specific decision that has severed a decades-long partnership, a decision that signals the end of an era. In exactly a few minutes, I'll tell you the name of the technology that made this divorce not just possible, but inevitable. At Revo Now, we look past the headlines, into the silent revolutions shaping our future. Today, we're not just talking about corporate breakups, we're talking about the future of technology, global supply chains, and economic independence. By the end of this video, you'll understand a critical shift happening in the semiconductor industry, one that could impact your devices, your investments, and the balance of global power. This isn't just business news, this is the future being restructured. For decades, the global semiconductor industry operated on a model of deep interdependence. Companies like Intel, based in the US, designed and manufactured cutting-edge processors. These chips powered devices worldwide. China, with its massive consumer market and growing tech sector, became a crucial customer and, increasingly, a competitor. We all know the story of globalization. US tech giants sold their products in China. Chinese manufacturers relied on US-designed chips and software. This symbiotic relationship fueled growth for both sides. Intel, despite facing challenges from AMD and others, maintained a significant presence in the Asian market, including China. Its chips powered everything from servers to consumer electronics across the region. Meanwhile, demand for chips continued to explode. The AI revolution, the Internet of Things, 5G networks, electric vehicles, all require powerful, specialized processors. The semiconductor industry is projected to reach over $1 trillion in revenue by 2030. The US and China were locked in a complex dance, competitors yes, but also deeply entwined economically. However, this harmony began to fray. The US-China tech war introduced export controls, blacklists, and restrictions on advanced chip sales to specific Chinese companies. Trade tensions simmered, but these were largely seen as tactical moves, temporary disruptions in an otherwise stable relationship. But what you're not hearing is the story of a fundamental strategic realignment, a divorce not just of convenience, but of core technological philosophy and national ambition. Let's talk about China's Made in China 2025 initiative and its subsequent more focused self-reliance push. The goal has always been clear. Reduce dependence on foreign technology, especially in strategically vital sectors like semiconductors. For years, this was seen as an ambitious, long-term project. What you're not hearing enough about is the speed and scale of China's recent advancements in chip design and manufacturing. Companies like SMIC have made significant progress in process nodes despite US export controls. Design houses like HiSilicon, Huawei's ARM, have created sophisticated processors, even under sanctions. But here's the hidden development. China isn't just trying to match Western chip technology anymore. They are investing heavily in alternative architectures and emerging technologies where they can leapfrog traditional leaders. Think RISC-V, an open-source instruction set architecture, advanced packaging techniques, and specialized chips for AI and quantum computing. Furthermore, China has been building its own ecosystem. They've invested in domestic EDA, electronic design automation, software, essential for chip design. They are developing their own materials science for semiconductor production. They are training a new generation of chip engineers. This isn't just about building fabs, it's about building an independent technological foundation. But what you're not hearing is the specific moment when China decided it had reached a critical threshold, a point where reliance on a foreign supplier like Intel was not just risky, but unnecessary. Reports suggest that China's imports of certain categories of chips, particularly those previously dominated by Intel, have begun to decline significantly. Domestic alternatives are reaching a level of performance and reliability that makes foreign suppliers less attractive, especially given the geopolitical risks. This shift represents a quiet but profound change in the fundamental dynamics of the global chip market. Let's talk about speed. In the world of technology, the pace of innovation is relentless. What takes a decade one day can take a year the next. The acceleration effect in semiconductors is driven by AI, by the need for ever more specialized chips, and by fierce global competition. If we've seen China go from being heavily dependent on foreign chips to developing competitive domestic alternatives within a decade, consider how fast that progress accelerates when necessity becomes the mother of invention, backed by massive state investment. If China's internal R&D efforts, combined with strategic partnerships and acquisitions, have brought them to the brink of self-sufficiency in key areas in just a few years, imagine how quickly they can close the final gaps. The semiconductor industry is approaching several inflection points. The physical limits of traditional silicon are being reached. New materials, new architectures, new manufacturing techniques are emerging. This is where the acceleration effect is most pronounced. China, freed from the constraints of licensing proprietary technologies, can experiment more freely with these new frontiers. Compare the traditional cycle of Moore's law, predictable, incremental improvements, to the potential for revolutionary leaps in chip design and function. The timeline compression is real. If China has reached a point where its domestic chip ecosystem can meet the needs of its most critical industries, telecommunications, defense, AI, high-performance computing, then the economic incentive to continue purchasing from traditional Western suppliers like Intel diminishes rapidly. Timeline thinking. If China's internal progress has brought it to near self-sufficiency in a few years, what happens when that sufficiency becomes total? The divorce isn't just possible, it's logical. So, what does this mean for the relationship between China and Western chip giants like Intel? The trade tensions, the export controls, these were skirmishes. This potential divorce. This is a declaration of independence. A statement that the era of dependence is over. Think about the implications. This isn't just about buying fewer chips. This is about a fundamental shift in trust, in strategic alignment, and in the very nature of the technological partnership that underpinned the digital age. The technology isn't the only thing changing. The rules of engagement are being rewritten. We're getting closer to the real reason this shift feels so final. It's not just about competition, it's about a complete realignment of technological ecosystems. There's one more piece you need to understand: the specific technological capability that made this independence not just desirable, but achievable. In exactly a few minutes, I'll tell you the name of the breakthrough that sealed the deal. Consider the strategic importance of semiconductors. They are the foundation of military technology, artificial intelligence, telecommunications, and countless other critical sectors. A nation that controls its own chip supply chain gains immense strategic autonomy. It reduces its vulnerability to foreign sanctions and supply disruptions. It secures its technological future on its own terms. The international community is watching. Other nations are taking note of China's push for self-reliance. The groundwork for a new, bifurcated global tech landscape has been laid. The pieces are in place. And the potential impact on global tech leadership, supply chains, and the economy is enormous. The silent technological revolution might be about to reshape the entire playing field. The revelation, it's not just about building better chips, it's about embracing an open-source, collaborative architecture called RISC-V, and combining it with China's massive domestic manufacturing and design capabilities. RISC-V is an open-source instruction set architecture, ISAA. Unlike proprietary ISAs owned by companies like Intel, x86, or ARM, RISC-V is free to use, modify, and implement by anyone. This removes a major dependency and licensing cost. Chinese companies and research institutions have thrown their weight behind RISC-V, investing heavily in developing cores, tools, and entire chip designs based on this open standard. This isn't just theoretical. Chinese firms are now producing competitive RISC-V-based processors for a range of applications, from low-power IoT devices to high-performance computing cores. They are building the software ecosystem, the development tools, and the supply chains needed to support this new architecture. They are creating a complete alternative to the traditional Western-dominated chip ecosystem. Optimistically, this shift towards RISC-V represents a democratization of chip design. It lowers the barriers to entry for innovation, It allows for greater customization and specialization. It could lead to a more diverse and resilient global semiconductor industry, where no single nation or company holds a chokehold on a critical technology. It fosters global collaboration on an open standard, potentially accelerating innovation for everyone. But here's the cautionary side. A bifurcated world, where the West uses x86 ARM and China, and potentially others, uses RISC-V, creates fragmentation. It makes global interoperability more difficult. It could slow down the pace of innovation if ecosystems become isolated. It shifts the balance of power, creating a new center of technological gravity outside the traditional Western hubs. And the decisiveness with which China has embraced RISC-V signals a clear intent to build a technological future independent of Silicon Valley. The divorce isn't just about chips. It's about choosing a different technological path altogether. Now that you know, it's your turn to weigh in. Is this a healthy evolution towards a more diverse and open global tech ecosystem? Or is it the beginning of a dangerous technological Cold War that fragments innovation? Should the West embrace open standards like RISC-V to remain competitive and collaborative? Should there be efforts to prevent technological bifurcation, or is a multipolar tech world inevitable and perhaps even beneficial? How should companies like Intel adapt to a world where their proprietary architectures might become less dominant? This isn't just about tech. It's about who controls tomorrow. It's about the silent revolutions happening not just in labs and fabs, but in boardrooms and government ministries, shaping the future of global connectivity and competition. You, the viewer, are now part of the few who understand the scale of this potential shift. The implications extend far beyond a single company or even a single country. They touch on the future of how the world computes. So what do you think? Drop your thoughts in the comments below. Do you believe this great chip divorce is a positive step towards innovation or a threat to global technological unity? What does the rise of RISC-V mean for the future of computing? Like this video if it opened your eyes to this hidden technological revolution, and subscribe to Revo now for more deep dives into the forces reshaping our world and beyond. Thanks for watching. This is Revo now, decoding tomorrow's hidden tech landscape today.